an and bn be sequence of positive real numbers satisfying the given condition. This, if the radius of convergence of the power series summation a and x raised to the power n is 4, then the power series has radius of convergence. Now, radius of convergence you can evaluate with the help of two methods. One is ratio method and known as limit n tending to infinity mod of un upon un plus 1. And the second is root test, limit n tending to infinity un raised to the power 1 upon n, and take reciprocal of this one. These are two very commonly known method to find radius of convergence, but which one applicable or convenient, it comes from the practice. So radius of convergence of series an x raised to the power n is 4, and given condition n a n less than b n less than n square a n, this condition is given. So we have to find a condition or inequality in terms of un raised to the power 1 upon n for bn. For bn, actually we need to find radius of convergence of series bn x raised to the power n. So try to make format of this series in this type. So take nth root of this inequality an raised to the power 1 upon n less than bn raised to the power 1 upon n less than n square an raised to the power 1 upon n. So this is nth root, and take reciprocal of this one, or you can understand limit. Try to take limit n tending to infinity n a n raised to the power 1 upon n less than limit b n raised to the power 1 upon n less than. So this is n a n. So you can write n and limit of this one n into n into a n raised to the power this. Okay. So take reciprocal, limit n raised to the power 1 upon n into a n raised to the power 1 upon n greater than, because in reciprocal sign of inequality change. 1 upon limit bn raised to the power 1 upon n greater than 1 upon limit n raised to the power 1 upon n into an raised to the power 1 upon n. Actually, we know that limit of n raised to the power 1 upon n is 1. So use this fact. So what we have? We have 1 upon 1 into limit an raised to the power 1 upon n greater than 1 upon limit bn raised to the power 1 upon n greater than 1 upon 1 into limit an raised to the power 1 upon n, and 1 upon limit an. So this one is radius of convergence of an, and radius of convergence is 4. So 4 upon 1 greater than radius of convergence of series Bn x raised to the power n. This is radius of convergence of An. Means radius of convergence of this series is greater than 4 and less than 4. It means equals to 4. So radius of convergence ROC of series summation Bn x raised to the power n is 4. Now we have radius of convergence. So for values, for mod values of x and less than radius of convergence, always series convergent, option A is true. And for all x, but series is convergent for mod x less than 4 only. At boundary points and points outside the radius 4, you can understand this is a disk of radius 4. Outside the 4 radius, series will be divergent. So this one is false statement, does not converges for any x greater than 2, but series is convergent for mod x equals to 3, and this is greater than 2. So this statement is again false, and series is convergent for any x which is mod value less than 2, but given does not converge. So false. Option A is right one.